long ride and just couldn't get comfortable no matter how much you adjusted to it? Or have you noticed that different cars can feel different, and also, even in the same car, you have a preference for a certain seat? Now, why does that happen? And more importantly, how can it be fixed for every type of body even before building the prototype? Hello everyone, I'm Anika, and this project has been developed under the supervision of Dr. Park and Dr. Jung and is supported by Hyundai Motors and the University of Michigan Transportation and Research Institute Biosciences Group. This study aims to answer those questions through a data driven approach to car seat design. So, why is this study so important? Seat comfort can impact multiple things, including driver safety, partial fatigue, and customer satisfaction. Most of the traditional car designs rely on physical prototyping, which makes it time consuming and expensive and can also be inflexible for different body types, which is why the idea of this study is to replace intuition with data and AI. The study began with collection of data, which would be multiple participants who were tested across different types of seats, and the pressure data was calculated using a 40-degree pressure mat for both the back of the seat and the cushion part of the seat. Then, avatars were generated using those 3D body scans to fit multiple participants. The avatars were then used to align the data, which is the 3D body scan that was collected for multiple participants. This allowed to extract the different features that would be used for the machine learning model development, as well as to calculate the overlap volume, which is a crucial factor for calculating the perceived pressure and the comfort. A brief overview to the end-to-end architecture of developing the machine learning model and eventually the comfortability prediction score would, can be seen in this figure. And as it shows, anthropometric data was used to predict the body pressure distribution, and later it was used to predict the comfortability score. And currently, we are working on improving the comfortability score and um, and eventually deploy it and make it more production friendly before deployment. So the eventual goal is to set up an application in production that would allow the ergonomic design of seat by the manufacturers based on the comfortability score, and they would input their conditions and would eventually have a virtual seat test score that would allow them to make strategic decision on how they would design a certain seat and eventually provide a good user experience. Now, moving into the workflow for the body pressure distribution. So, this takes in the anthropometric data as we talked about, which would include the sit property, the body characteristics, the type of seat, and the overlap volume that we calculated. And all of these values were input as principal component score, and it was done to reduce the dimensionality. So this algorithm takes in 20 different types of pressure PC scores for the body characteristics, the seat, um, and the body dimensions, and eventually it would output 20 different pressure PC scores for the as the output. And as for the evaluation metric, R squared was used because it is scale independent, and also mean squared error was also used. But to compare the different performances of the machine learning models, we stuck with the R squared value. And while developing the machine learning algorithm and fixing on the ultimate approach, we did have to go through a lot of trial and error, where were tried out different machine learning models and compared them. We tried out deep learning, regression analysis, and others to eventually come to a conclusion that we would be sticking to a hybrid approach, which we will talk about in a little bit. And it also, we did the same for the comfortability score, and right now, as we can see, um, that what we can see is that the fast decision trees could be a good model for predicting the comfortability score in the production environment, but it is not finalized yet. But that is one assumption that we have based on the R squared error. So the comfortability score can be divided, or it is actually divided into 6 different zones, and for each of the different seat property levels. So for the seat back, we consider the top, bottom, and the bolster. And for the cushion, we consider the front, rear, and the sides. And this helps to make the study more granular and make the seat design study more efficient. So, as we were talking about in terms of the results, we figured, so this shows the top 20 variables that were identified to impact the prediction of pressure. So what it means is, so eventually what we figured is, from the list of features that was input into the machine learning model, we used regression analysis to list the top 10 or the top 20 features that impacted the pressure prediction or accuracy. And we came up to a conclusion where we decided for each of the output variable, we would use a separate model to predict them. So eventually, the idea is to have a hybrid kind of approach. And as you can see, that approach has been successful because these are the constructed pressures based on the predictions from, and the original and the reconstructed pressure looks pretty much similar. So to conclude, this study combines sensor-based data, ground truth, and AI to produce fast and interpretable and accurate predictions of body pressure distribution and comfortability score, and would help with virtual test of seats and to design more comfortable seats in the process. So hope you enjoyed the presentation, and I would love to answer any queries that you may have, and please feel free to reach out. Thank you so much.